We are going to be looking at the volume, capacity, and surface area of 3D shapes. We are first going to have a look at the volume, capacity, and surface area of cubes. We need to understand what the properties of a cube is in order to know what the formula for the volume, capacity, and surface area of our cube will be. So we know that a cube has 6 faces. It has a top and a bottom. It has 2 sides, and it has a front and a back. So we need to understand that a cube has 6 faces, and we also need to understand that each of the cube's edges are equal. So all the sides in each of the faces are equal. So because this measurement from there to there is 3 meters, then we know that all the other sides or all the other edges will also be 3 meters. So let's have a look at the formula for volume. Volume is equal to length times breadth, which is exactly the same as your area, and then multiply that by your depth. So what we can also say is that volume is equal to height times width times depth. There are a number of different formulae that you can use, as long as what you are doing is you are multiplying the width or the base there by the height and then by the depth. So you basically are timesing those 3 measurements together. So whatever you happen to call those measurements doesn't really matter, as long as you are multiplying those 3 measurements, and they must be those 3 different measurements together. So because our area is equal to length times breadth, if you are given the area of one of the faces of a cube, so for instance, if we have been given that this length times the breadth, well, it doesn't matter which one we call them because they are equal to each other in a cube. So this face over here, this face at the front, if we are told that that is equal to 3 by 3, which we know is equal to 9 meters squared, I beg your pardon, then all we need to do is multiply our area by the depth, which we know is also 3 meters. So we would then multiply our area, which is 9 meters squared, by our depth, which is 3 meters, or 3 meters to the power of 1, and we would end up with an answer of 27 meters cubed. And the reason that it's meters cubed is because we are now multiplying 3 measurements together. So let's just plug in our values here. So we end up multiplying 3 by 3 by 3. And to be more accurate, this is 3 meters by 3 meters by 3 meters. So when we are multiplying 3 by 3 by 3, we get an answer of 27. 3 by 3 is 9, and 9 times 3 is 27. But now remember, we also need to multiply our measurements together. So remember, these are all to the power of 1, an imaginary one. We don't need to put those ones there. It's just to help us understand. And when we are multiplying numbers that are the same, or in this case, measurements that are exactly the same, we just plus those powers together. So we end up with meters. So meters times meters will be meters squared, which is what we use with area, like we did there. But now we are working with volume, so your measurement is going to be cubed, because we say meters times meters, which is meters squared, and meters squared times meters to the power of 1 is equal to meters cubed. So basically we're just saying that there are 3 of those measurements that we multiplied together. Right, so the answer to the volume of this cube with a side of 3 meters will be 27 meters cubed. Right, so now when we are moving from meters cubed, which is our volume answer, into capacity, we need to remember our little rule on the side is that 1 meter is equal to 1,000 centimeters, right? Beg your pardon, 100 centimeters. Okay. Now 1 meter squared, so these were to the power of 1. 1 meter squared is equal to how many centimeters squared? Well, what did we do here? We multiplied our meters by our conversion to the power of 1. So here we need to multiply our conversion, which is 100, to the power of 2, which is going to be equal to 10,000. So 1 meter squared multiplied by 10,000 is 10,000 centimeters squared. Now 1 meter cubed is just going to be equal to how many centimeters cubed? Well, we multiply it by our conversion, which is still 100, and we cube that measurement. Right, so 1 meter cubed is going to be equal to 1 million. 1 meter cubed is equal to 1 million centimeters cubed. Right, so we need to also have an understanding that centimeters cubed, which we have there, is equal to milliliters. So 1 centimeter cubed is equal to 1 milliliter. And that is a very important thing to know. That conversion is very important to know because that helps us convert our meters cubed or our centimeters cubed into milliliters, which is what we measure our capacity in. So milliliters or liters. Right, so when we have our measurement in centimeters cubed, we can just replace that measurement with milliliters. But when we are working with meters cubed, we first need to multiply that number by 1,000,000 to get our answer in centimeters cubed or milliliters because they are the same. And then what we do is divide it by 1,000 to get our answer in liters if we would like our answer in liters, if the number is big enough. So let's just have a look here. We are working with 27 meters cubed. So 27 meters cubed. We would like to convert this number, this measurement, into centimeters cubed. So 27 meters cubed, remember we multiply by our conversion, which is 100, to the power of 3, which gives us 1,000,000. So that will give us an answer of 27 million centimeters cubed. And remember that centimeters cubed is equal to milliliters. So that will also give us 27 million milliliters because those two measurements are exactly the same. Now, because this is quite a big number, we can divide our milliliters by 1,000 to get our answer in liters. So we divide 1, 2, 3 spaces by 1,000 and we end up with 27,000 liters. So that's the answer for the capacity of this cube. So how many liters will this, how much water will this cube be able to fill? The answer will be 27,000 liters will be able to fit into this cube of side 3 meters. So this answer here is your capacity. Right. So as you can see, what we can do when our measurement is in meters cubed, as it was here, we've got our meters cubed answer. What you can do is just times this number by 1,000 and then you get your answer straight into liters. So going from meters cubed into liters, you just multiply by 1,000. And then going from centimeters cubed into milliliters, you just times by 1, or you don't need to do anything because timesing by 1 will give you exactly the same answer. So going from our volume, which is in meters cubed or centimeters cubed, into capacity, which is liters or milliliters. Going from meters cubed to liters, you multiply by 1,000, and centimeters cubed into milliliters, you don't do anything, you just change the measurement, or you just multiply it by 1. So that is your capacity. Let's now have a look at our surface area. So surface area is a slightly different concept because we are not working with the inside of our 3D shape, we are working with the outside of our 3D shape. So a nice way to think about it is if you would like to cover this cube with wrapping paper, how much wrapping paper will you need? And that's basically saying that there will be no wrapping paper to spare. So we're wanting to know the exact amount of wrapping paper to cover all the faces on this cube. So we are not going inside the cube, so we won't be working with cubed measurements. We will be working with area. As you can see there, it's area. So let's have a look. The formula for the surface area is length times breadth. So length times breadth, which is the formula for our area. But you need to work out the length times breadth. So you need to work out the area of each of the faces on your 3D shape. So with our cube, we are lucky because all our faces will have exactly the same area. So there's the area of one of our faces, and because we have 6 faces, you multiply that area by 6. It's as simple as that. So when we're working with a cube, it's very simple and it's quite nice and easy. So we know that all our sides or all our edges are equal. So the length times breadth is pretty basic. It's just going to be 3 meters times 3 meters. And we multiply that answer by 6. So 3 meters by 3 meters is equal to 9 meters squared. And 9 meters squared we multiply by 6 to get an answer of 54 meters squared. So the surface area of this cube with a side or an edge of 3 meters will be equal to 54 meters squared. We are going to have a look at another cube and try and work out the volume, capacity and surface area of this cube with sides of 7 centimeters. So remember that the volume with any cube is just equal to that side multiplied by itself 3 times, or we can say that the volume is equal to side cubed, which is equal to 7 centimeters multiplied by 7 centimeters multiplied by 7 centimeters, and that gives us an answer of 7 by 7, which is 49, and then times by 7 again will give us an answer of 343. And because remember we're multiplying our centimeters, our measurement as well, because there are 3 of these measurements now, we have our measurement cubed. So our answer for the volume of this cube is 7 by 7 by 7, which is 343 centimeters cubed. So that is our volume. If we would now like to work out our capacity, remember that centimeters cubed is equal to milliliters. So our capacity is simply 343 milliliters. We do not need to convert this measurement into liters because it is we do not have more than 1,000 milliliters here. But if the question asked you to convert the measurement to answer your capacity question in liters, all you need to do is divide your milliliters by 1,000 to get an answer of 0.343 liters. Right, let's now have a look at our surface area. Remember that the surface area of any cube is just working out what the area of one of our faces will be, which in this case will be 7 by 7. So let's just write down our formula, which is equal to length times breadth. And then we multiply that by 6. Or you can put your 6 at the front of your brackets. It doesn't make a difference. So length times breadth is equal to 7 multiplied by 7. And then we multiply that by 6. So remember that your 7s are in centimeters. So 7 by 7 is 49, and then centimeters squared. If we multiply that by 6, we end up with an answer of 294 centimeters squared. So the surface area for this cube with sides of 7 centimeters is equal to 294 centimeters squared. When we are working out the volume capacity and surface area of a rectangular prism or a cuboid, we need to follow slightly more careful steps in working out these three measurements. So if we're working with the volume of a rectangular prism or cuboid, we need to multiply the length by the height and then by the depth. So we say length times height times depth. So just remember that it is those three measurements that you need to multiply by each other, and it doesn't really matter what you call them here as long as it's those three different measurements that you multiply together. So our length there is 9 meters multiplied by our height, which is there, 6 meters, and then by our depth, which is there or there, which is 3 meters. So now we have 9 multiplied by 6 multiplied by 3, and that will give us an answer of 162. And because we are working in meters, we say meters times meters times meters, which gives us an answer of meters cubed. So the volume of this rectangular prism, 9 meters by 3 meters by 6 meters, will give us an answer of 162 meters cubed. Now remember that the capacity of our rectangular prism, when we get our volume in meters cubed, all we need to do to our meters cubed answer is multiply it by 1000, and that will give us our answer in liters. So 162 multiplied by 1000 gives us 162,000 liters. And that is our answer for the capacity of this rectangular prism. Let's now have a look at our surface area. So the surface area of a rectangular prism is quite a bit more complicated than the surface area of a cube, and the reason for that is because we do not have faces that are all equal to each other. So we do have the front face, so this face over here, that face will be equal to the face at the back. So those two faces will be equal to each other. We will also have these two side faces that will be equal to each other, and we will then have our top two faces, or our top and bottom face rather. That top face and this bottom face will be equal to each other as well. So we just need to work very carefully. We will have to work out the area of 3 faces, the top, one of the sides, and the front or the back. We need to work out each of those areas, and then we need to plus them. Well, we need to first multiply those areas by 2 because we know that there are 2 of them, and then we plus those areas together and we get our final surface area. Right, so we need to make some more space. So surface area is equal to, let's start with our one of the front or the back face. The front or the back face will be 9 by 6. So that's 2 times by 9 by 6. And we just remember that these measurements will all be meters squared. And then we plus 2 multiplied by, let's do one of our sides, so that's 6 meters by 3 meters. So that's 6 by 3. And then we plus 2 times by one of our top face or our bottom face. So that's there, which is 9 by 3. Right. So we obviously now need to work out what each of these brackets is equal to. So that equals to 2 multiplied by 9 times 6, which is equal to 54. And then we plus 2 multiplied by 6 times 3, which is 18. Then we plus 2 multiplied by 9 times 3, which is 27. So this is obviously quite a lot of working out, but if you work those out, what you will end up with is 2 times 54 is 108, plus 2 times 18, which is 36, plus 2 times 27, which is 54, and then you just add those all together, and you get an answer of 198. And then remember, our answer is in meters squared because all these measurements were in meters squared. Right, so the surface area of this rectangular prism is 198 meters squared. So remember that the measurement for your surface area will always be in measurement squared, not in measurement cubed, but your volume will always be in your measurement cubed. Let's now have a look at another rectangular prism and try and find the volume capacity and surface area of this prism that has a length of 24 centimeters, a height of 12 centimeters, and a depth of 8 centimeters. So the volume is equal to length times height times depth, and that is equal to 24 centimeters multiplied by 12 centimeters and then multiplied by 8 centimeters. Right, so that will give us an answer of 24 multiplied by 12 multiplied by 8 is 2304, and because we are multiplying centimeters by centimeters by centimeters, our answer is in centimeters cubed. Right, so the capacity of this rectangular prism is just going to be equal to our answer that we got in our volume, but it will obviously be in milliliters because remember that centimeters cubed and milliliters are equal to each other. They are interchangeable. So we've got 2,304 milliliters as our capacity. Right, let's now have a look at the surface area of our rectangular prism, which again we need to work out the face of the front or the back of our cube, of our prism rather, and multiply that by 2. We need to work out the volume, the area of one of our sides and multiply that by 2, and work out the area of our top or our bottom and multiply that by 2 as well. So let's first work with one of our front or back faces, which is 24 by 12. So we say 2 times 24 by 12. And then we plus 2 times, let's now do our sides, which is 8 by 12. So 8 there and 12 there. So that's 8 by 12. And then we plus 2 times our top and our bottom, or our top or our bottom, which will be 24 by 8. Right, so now what we need to do is do some calculations on the side, and then we add them all together. So we will end up with 24 by 12. So that's equal to 2 times 288. Then we plus 2 times 8 by 12, which is equal to 2 times 96. And then we plus 2 times 24 by 8, which is 2 times by 192. Right, so 2 times 288 is 576, and then we plus 2 times 96, which is 192, and then we plus 2 times 192, which is 384. And when we add all of those together, remember that these are each in centimeters squared. So when we add those together, we end up with an answer of 1152 centimeters squared. So the surface area of this rectangular prism or cuboid, which has dimensions 24 centimeters by 8 centimeters by 12 centimeters, will give us an answer of 1152 centimeters squared. We are going to have a look at the volume and capacity of cylinders. If we would like to work out the volume of a cylinder, remember that if we have got the area of one of the faces of our 3D shape, then we just need to times it by the other measurement that we need. So it could be the height or it could be the depth, depending on how the 3D shape has been laid down. So we have got the area of this cross section of this cylinder, which is 18 meters squared. So because we have already got the area, which is, so the volume of your cylinder is the area of the cross section of the cylinder, which will be a circular measurement. So you would need to use pi r squared to work out the area of that circle if you have not been given the area already. So it's the area, which is in meters cubed or centimeters cubed or millimeters cubed, and then you multiply that by, in this case, it is the height of the cylinder. But if the cylinder was lying in a different way, then you might call this measurement the depth. So it all depends on how the cylinder has been laid down. Okay, so the volume is the area multiplied by the height in this case, which is equal to 18 meters squared multiplied by 11 meters. And that will give us an answer of 198 meters cubed. So the volume of this cylinder is equal to 198 meters cubed. Right, now if we would like to give our capacity answer, we need to now convert our meters cubed into milliliters or liters. So remember that when we end up with a meters cubed answer with our volume, we just multiply that answer by 1000 and we will get our answer in liters. So 198 multiplied by 1000 is equal to 198,000 liters. So this cylinder will be able to hold 198,000 liters of water. If we would like to have a look at another cylinder that has an area of 27 centimeters squared and a height of 19 centimeters, what we need to do is multiply our area of the cross section by our height, which is 19 centimeters. Or let's just put our formula down first, which is our height. So the area is 27 centimeters squared. We multiply that by 19 centimeters, which is our height, and we end up with an answer of 513 centimeters cubed. So the volume of this cylinder is equal to 513 centimeters cubed. If we would now like to work out the capacity of this cylinder, we need to multiply our centimeters cubed by 1, or it can just stay the same, in order to get our answer in milliliters. So 513 multiplied by 1 is just 513, and this gives us our answer in milliliters. So 513 milliliters is the capacity of this cylinder. If we would like to work out the volume and capacity of a different type of prism, such as a pentagonal prism, remember that all we need is the area of one of the bases, or the top or the bottom cross section of our 3D shape. So obviously the cross section of a pentagonal prism will be a pentagon. So this pentagon there, if we have been given that area, we then just need to multiply that area by its height. So the height of our pentagonal prism, which is 1.2 meters. And we will then end up with the volume of this pentagonal prism. So whether it is a hexagonal prism or a heptagonal prism or an octagonal prism or a triangular prism, all we need to do is find the area of the cross section of that 3D shape or of that prism, and then we multiply it by the height or the depth of that prism, and we will end up with the volume of that 3D shape. Right, so the volume here is equal to the area of our cross section, which we know is equal to 1.4 meters squared, and we multiply that by the height of our prism, which is 1.2. So we end up with 1.4 meters squared multiplied by 1.2 meters, and that gives us an answer of 1.68 meters cubed. So the volume of this pentagonal prism is equal to 1.68 meters cubed. If we would like to find out what the capacity of this pentagonal prism is, we simply need to multiply our answer in meters cubed by 1000, and we will get our answer in liters. So 1.68, let's work it out, 1.68 multiplied by 1000, let's put a placeholder in there. That'll be equal to, we move our decimal point 1, 2, 3 places to the right because we are multiplying by 1000, which has 3 decimal places, and that gives us an answer of 1,680 liters. So this pentagonal prism will be able to hold 1,680 liters of liquid or water.